I want to continue to the next lecture regarding API and access is broken, and the one that is breaking, want to fix it. So Aviad is the CTO and actually the technical guy behind front-end solution. Guy, you are in mute. What are you saying?
Yeah, you can call it like that.
So, Guy, the stage is all yours. Please teach us how to fix what is broken and how to fix it.
Cool. So it's good that this lecture is finalizing because it will cover pretty much everything that we just talked about. So maybe just starting with myself. So Aviad, I'm the CTO and co-founder of FrontEgg. I also play the tuba, which is my rock and roll stuff, and obviously obsessed about Maccabi Haifa and that kind of stuff. Depends on whether I'm coding or doing some architecture. It's either classical or metal music, as pretty much all of us. So I'll try to be as fast as we can when we talk about numbers. So we just covered some of the OWASP. So yeah, broken access control just moved from number 5 to number 1 in the OWASP top 10, where the broken authentication, which was there a few years as number 1, number 2, number 1, number 2, is down to number 7, if I'm not mistaken. And the crazy number around it is that 94% of applications that were tested for some sort from PT or that kind of stuff were found vulnerable for broken access control. And these numbers are crazy because if you look at the number below, that's the number of Twitter, okay? Twitter is handling 70K calls, API calls per second. That results around 6 billion requests per day. And that's only Twitter. If you think about the numbers that Google are doing or Facebook are doing, or even the numbers that small, medium business APIs are doing, it's enormous. So when I talk to my guys about APIs, and when we go to design a new API, I keep telling them, listen guys, when you go to design an API, there are 3 questions that you need to ask yourself when you design this API. So the first question is, who are you, okay? And that's the question that is resolving around the user that is using your API. You need to ask him, who are you, okay? And that covers the authentication side. And then you need to ask him, where do you belong to? What is your context of request, okay? And after you know who is the user and where they belong to, you need to make sure that you know what he can do with this API, okay? And when you think about it, sorry. Yeah, so when you think about it, these 3 questions answer the 3 most important stuff around our APIs. The who are you covers the authentication side, okay? Where the where do you belong to cover the context. Which tenant? We are now in the world of multi-tenancy. Which tenant do you belong to? The worst nightmare that every API developer has is a data leak between tenancies. And the what can you do is what we covered about the broken access. It's the authorization context. Whether what are you eligible to do with your authentication on this API? So I won't cover on what is authentication. I think that after these 4 lectures, we have a general understanding of what authentication is, but I think the most important sentence around it is the authentication is a process of verifying identity, and we have so many identities today, but when we approach on our APIs, we need to make sure that we know the identity of the user/client who is trying to access our API. And you know, that's kind of the process of we either redirecting the user to an authentication or identity provider to access our API, but we need to know who they are. And some of the stuff around API authentication are obviously broken. Michael touched it on his lecture, and we see one of the most important or most of the more repetitive broken access around APIs is the session management, mishandling of how we are doing sessions. Okay, so let's look at this picture right here. So we see that the session ID is being passed as one of the query params. That's a mistake that some developers are doing, okay, because they want to speed up things and they want to just make sure that everything is okay. But you know, this means that the sessions are pretty much floating around the internet on all kinds of gateways in the middle. And in order to fix it, we need to use a server-side secure session management. We need to use HTTP onlys for this. And we need to make sure that we have a proper invalidation management for our sessions. And we see some great examples on how it looks like from the backend side, where we set cookies and the cookies are set as HTTP only, and we can implement a server logout to throw the user out. But session management is one of the most repetitive stuff that we see around authentication for APIs. And before we are thinking about reinventing the wheel, because that's what developers normally do, there is no reason to, okay? There are a bunch of open source libraries to handle sessions. There are a bunch of tools, okay? You shouldn't reinvent the wheel. So we fixed session management, and that's good. Let's move to the next stuff. So let's take a look at this code. Okay, so there's a nice code that you can find in the internet if you want to be really hacky tomorrow morning. And this code, basically what it does is trying to password spray, okay? So we are trying to attack John Doe. We are trying to authenticate as john@doe.com with some common passwords that we found online. So that means that we are trying to automate, okay? We have an automated attack. We are trying to password spray, user spray, all kinds of spraying around, trying to access the authentication, to attack the authentication API. And if we take a look at the public APIs, so password spraying, DDoS attacks, all of this kind of stuff can be easily solved with just, you know, basic mechanisms around reCAPTCHAs, IP filtering, limits and increasing limits on delay, on denied logins, and the idea that we are able to block session in any given time. And, you know, the code for rate limiting, you know, that's a Node.js example, is so simple that it's like a crime not to add it to any of your API gateways, okay? It's just a matter of thinking on it up front and just implementing it. And one additional thing that we need to do, and that's extremely important, is to log everything, because when the shit hits the fan, we want to make sure that we know what exactly happens, because we need to print what is the IP address of the request, who is the origin, user agents, okay? Bots are trying to attack us through user agents. And when we print everything, okay, this is how we know to tackle these issues. So as I mentioned, we want to fix the automated attacks by implementing a user lookup mechanism, using tools like reCAPTCHA or any other bot mechanisms, and even start delaying the users, okay, to make sure that we can lock them out if they're trying to attack us. So when we are verifying our user identity, I'll jump a little bit into it. There are two main approaches on how to handle identities. JWTs, which is the most popular today, JSON Web Tokens, and session-based. So the idea with when we compare JSON Web Token to a session-based, it will hit us when we are building distributed application. Because if we take a look at it, when we are doing session-based authentication, for each request, we are validating the request through the server. Well, when we are doing JWT-based authentication, it only takes a signed token and a simple verification. And it even can be verified on the client side. And if we are building a distributed application, okay, so we see that for each request from the client, okay, to the resource server, we are going to the auth server to validate the session. And that means that we have a single point of failure here. And that means that the requests are going through the auth server for each and every call. While in the JWT-based authentication, the resource server can validate the request on his own because he holds the public key. Okay, so the authentication is signed by the authorization server and is validated by the resource server. And if we see the difference between it, that means that the client now can even validate the JWT on his own because the public key is known for everyone through tools like JWKs. But when you want to implement an immediate logout, okay, that's when you need the help of session-based. And the bottom line, okay, most of the customers we see use JWTs, but hybrid modes where you add another session on top of the JWT for this server logouts is the modern application today. So I'll just cover that. We talked about it in Sagi's lecture. Authentication is not what it used to be. It's different today. Username, password, email password, okay? It's like the world has evolved, okay? And that means that today, because of data breaches, we are seeing that's crazy numbers. 53% of people admit that they are using the same password for multiple accounts. That's crazy because it only takes one breach for one DB, okay, to hack into all of your accounts, and that's crazy. So that means that we want to make sure that our users are protected. They are using passwordless. You don't need to use passwords anymore, okay? We want to make sure that we support multi-factor authentication everywhere, okay? Email even is not protected today. You want to use another factor for everything. And if you're taking it from a corporate standpoint, okay, SSO everywhere, okay? So when your employees leave the organization, okay, it only takes one place to remove them, okay? So we talked a little bit about the authentication stuff, but authentication alone is not enough. Michael, I saw your question on OAuth 2 as JWT authentication. So OAuth 2 is a protocol to generate eventually JWT authentication. So yeah, JWT is the mechanism, but OAuth is the protocol, one of the protocols. So OpenID Connect, which wraps OAuth to generate eventually JWT authentications. Yes, and then it holds some sort of session management on top of it as well. So as I mentioned, we covered the authentication, but authentication is not enough in order to protect our APIs because the context is what really matters. So let's take a look at this flow. So our client is authenticating through the authorization server, and then he's trying to access the resource server to access some sort of resource, okay? And he's trying to get a data based on a token. So the token that is being passed there for this scenario is a JWT, okay? But then we need to make sure what exactly is the data that we wanna supply with. So one of the most repetitive issues when you are building a multi-tenant application is the bypassing access control. Whether you are modifying the URL, you are passing the tenant ID or the user ID through the URL, or even if you are trying to use data of another user's or tenant context, and you are not allowed to. So if you take a look at this JWT, for example, okay, this is mine JWT from Frontech. So Frontech, in Frontech, what we are doing, and I didn't introduce ourselves basically, is providing a way for application to become self-serve by providing all the relevant stacks on top of the self-serve application. And one of them is the authentication and administration of accounts. So this is the JWT token issued by Frontech for one of our customers, okay? And it holds the user information, but on top of the user information, okay, I have a tenant ID which I belong to, some UUID. So if I'm trying to access this API, okay, to get the users of tenant 1111111, what do you think should happen? I should be blocked, okay? And I should be blocked because I'm trying to access these 1111 users with a JWT that belongs to another tenant. And the way, basically, because everyone are built today microservice-based platform, the way to ensure that this is happening is to do this stuff around in your API gateway. Make your API gateway the one that validates the authentication and passing the context, okay, via reverse proxy to the microservices that hides behind you. Okay, you don't want the microservices to be exposed to the other world. And when you do that, okay, don't forget to remove any other incoming header, because then you'll be exposed if someone is passing tenant ID header, okay, you'll be exposed to that as well. And another thing that you might want to think about when you're designing your API is maybe trying to avoid, for your own sake, trying to avoid route params, okay, or query params for tenant ID, user ID, all kind of this stuff, okay, because it only takes one place to forget and you are exposed. Okay, and if you do choose to use these query params and route params, use guards on top of them to make sure that they are aligned with the context that you are currently in. So this is a great GraphQL example on how to resolve your context around GraphQL. So there's always a context resolver in GraphQL. You always verify the JWT, and when you verify the JWT, you make sure that once you query the GraphQL APIs, you always have it in the right context. Okay, so we fixed API context. So we have API authentication fixed and API context fixed, but that still leaves us with an authorization problems. So one of the most common issues around authorization with APIs will be the elevation of privileges. So I'm a user, but actually I'm trying to pretend to be an admin, and I'm trying to exploit all kinds of open APIs in the system, trying to basically elevate my permissions and trying to access data that I'm not authorized to see. And if we think about some use cases around it, so for example, I'm trying to access a private GitHub repository, also, although I'm not allowed to. I'm trying to access, I have a pro plan, and I'm trying to access features from the enterprise plan. I'm trying to access a repository of a different team in the same organization. Also, I'm not allowed to, okay? Or even in the feature flags world where developers really like it, I'm trying to access hidden features. Also, I'm not allowed to. And there are many techniques to do that. You can tweak the access token. You can try to manipulate the account. Access token manipulation appears twice, so yeah, that's one of the most common techniques. And we covered on the authentication. You are authenticated or non-authenticated, and you're trying to access an authenticated API as someone else. And this is what I like most when you're talking about authorization. In my position in Fronteg, I meet a lot of startups and a lot of companies every week. And we are talking a lot about authorizations. And when you think about the common scenarios to do authorization enforcements and authorization checks, the most common one will be the role-based access, right? You wanna separate the viewer from the admin. You want to separate the operator from the admin. You are creating different roles in the system. You're attaching them with the permissions, and that mostly will do when you get started. And then you start adding more and more capabilities, okay? And there comes the VP sales or the CEO and says, yeah, let's add subscription. Let's start make them to pay more. When then you add subscription, and you want to make sure that you're protecting specific areas of the product with subscription and enforcement around subscription, and that is not related to the roles of the user. Okay, and then comes a product manager and say, well, let's start doing A/B testing. So you are protecting some stuff around the plans with A/B testing, and you want to make sure that just 10% of the user sees that. And if you have a really complex scenario, you'll do entity-based. It's not related. The fact that I'm an admin on my organization and I'm paying is not related to which folders and which files I can see because someone collaborated them with me. So you see, there are all kinds of authorization schemas that can be applied. And if you think about it, it all starts with RBAC, but then it goes up to the most advanced scenarios. And when you think on how it's a bit overwhelming. So how do I handle it? Okay. So the first guideline is that deny by default. Everything should be denied by default. There should be 2 public APIs. One of them is the authentication, okay, and reset password, and that's it. All of the others should be denied by default, okay? And you want to implement an access control mechanisms on each and every one of your APIs, and to make sure that you know how to distinguish the read capable APIs from the modify capable APIs, and you are modeling your APIs around this. Okay, because it will make your job easier as a developer to distinguish where you can fail. Okay, and the idea is that once you apply these requirements around your APIs, your domain models should apply and enforce them. Okay, and when you think about the old way that we did stuff, so you know, if we are doing role-based access, we can put the roles and permissions on the JWT and enforce them in one place. That's okay. Okay, there is no issue over there. Okay, but what happens when you want to deal with entities? What happens when you have a hierarchy? What happens when you have feature flags? Can you put it on your JWT as well? Well, you can put it on the JWT, but then you'll hit one of the world's most famous problem with web and HTTP headers is the size of the HTTP headers. You'll get blocked. And when you get blocked, this is what happens, okay? Your application starts crashing in no time, okay? And then it's chaos engineering. So today, there are two very famous way of doing stuff, which is far beyond RBAC, role-based access control. You define policies, okay? There are two great libraries around this policy as code methods. And when you define these policies, okay, you enforce everything on the backend side, and suddenly the authentication is just another tool that you have in your set of tools. So when you think about the flow now, so the client, okay, is going to the API gateway, which is validating the authentication and validating the context, but now the resource server validating the actual authorization around the request because it has the relevant context and it has the relevant library, whether it's Open Policy Agent also, or any other library that is doing authorization checks, whether you have implemented it your own, okay? The way to do it is in the resource server. So if we summarize, and that's, I believe, my last slide, going to implement an API, no matter what API is, you always have to think about these three questions. So we talked about the who you are. Who are you is basically answers the authentication, okay? And on the authentication, you have to think about authentication problems. Authentication about JWT, you have to think about rate limits. You have to think about anti-automation tools. Okay, we talked about reCAPTCHA, we talked about locks, we talked about some kind of rate limits. And when you pass the authentication, you have to make sure that the right context is always passed along to the microservices and it always gets enforced, okay? So then you talk about the multi-tenancy, you talked about the user context, and you talked about the path controls and the guards. And the authorization is the last piece of the puzzle that you need to make sure that you are aware of, okay? Whether it's role-based access control and then you only validate in the roles, you always make sure that you enforce the record ownership. If a client trying to access a record through your API, you need to make sure that he owns this record. He is allowed to see the record. And you want to deny by default, because if the answer is not known, the answer is no. And that's about it.